My name is Victor, and I'll be talking today about GitOps. I will do a short demo, but it's more about conceptual level and the objectives. And those are the same objectives that we are trying to apply either in our practices or in our products and stuff like that. So I want to walk you through what I consider to be GitOps and the rules that I believe we should be following, right? No matter the tools we use. So I will, as I said before, I will show you a tool, but more to demonstrate something than really to promote the tool itself. So this is how I look like. I work for CloudWiz. We're a company behind Jenkins, some other products, blah, blah, blah. There are guys from sales. They will give you a pitch. I work for Docker. I work with Kubernetes a lot. I have blog, books, YouTube. No, not YouTube. Twitter. Doesn't matter. Really. So before I started, what I did, just not to waste your time, I executed a single command, this one that you see at the bottom, to create a cluster. So I created it like 10 minutes ago, something like that. A cluster with everything I need. With Tekton, with Knative, with it's a Kubernetes cluster, auto-scalable, Jenkins X, a lot of stuff, right? Single command and not really much more. You will see it in action very soon. So I'm going to skip creating a cluster, blah, blah, blah. Okay, so let's talk about who is not using Git here exclusively. No SVM people here.
I'm sorry.
Yeah. Yeah, you need to find a VIP and go through a street punishing yourself for yeah, you should. At least you understand that you need to repent. That's okay. So everybody else, everybody today is using some flavor of Git, whether it's GitHub, GitLab, does not really matter which one, you're using Git. So that's very clear. And what should be clear, at least to developers here, is that everything we do ends up in Git, right? Which happens to be a bit less clear for infrastructure and a bit more, even less clear for testers, and definitely confusing for business analysts. You know, those people who now change their titles to product owners or whatever you are. Anyway, the point with Git and where we are, I believe, as industry, is that Git is the only source of truth, right? There is no other place where the complete truth about everything you're doing is stored, right? Does anybody disagree with that? Nobody? Huh? Jira is not a source of truth, it's a source of confusion, right? So kind of, yeah, let's open 7 tickets so that we get the server and things like that. Okay, so, but yeah, I mean, incidences and stuff like that, that's not really the truth I'm talking about. I'm talking about the code, I'm talking about configurations, I'm talking about test cases, I'm talking about requirements, I'm talking about everything that defines your application. And if you want to copy it and paste it in Jira, that's okay. It's your problem. Okay, so that's a really starting premise of GitOps. Git is the only source of truth. And that means, as I said before, code is there, tests are there, scripts are there, pipelines are there, configurations are there, everything is there. And you are not allowed to change anything in your system without committing something to Git. Very simple, very straightforward. And yet most of you will not admit that you're not doing it. But that's a separate story. Okay, so I'm going to start by importing a project to the system because I'm going to tell you a few of the rules that I believe you should be following, and I'm going to do them as well. I'm just going to create a quick project. I'm going to create a project based on application based on Go. I'm going to call it JXGo, and it's just going to create stuff while I'm talking, right? I'm just creating a new project starting from scratch. So now I know that this is a highly religious country, and I know that you're not going to follow any rules unless it's told from above. So consider those next 10 commandments spoken by the higher deity and commanding you what to do, because I know you're not going to follow it otherwise. So the first one, Git is the only source of truth. Everybody here puts things in Git. You don't put it to Jira. You don't put it to Excel sheets, no Word documents. What else? No Google Drive and all those things, right? And it's very easy because Git is where we store things, Git is where we track things, and so on and so forth. It's an excellent tool. There is no reason to use it. So what that really means is that you are allowed to push something to Git. Very simple. What is not so simple is that you're not allowed to do anything else, right? So those of you having SSH access because you think it's cool to enter into one of the servers and do random stuff, you're not supposed to do that, right? And those of you who think it's cool to write test cases in Excel, you're not supposed to do that. You are pushing to Git. Your only job, the only thing that all of you should do is push things to Git. That's all. There's nothing else for you to do. Very simple, you can go home. Okay, so if that's the only first rule and that's the only thing you need to do, let me make a change to my code and push it to Git. So I'm just gonna change a file, main Go to, who's using Go here? Shame, everybody else. Java, right? COBOL, anybody from banks? Okay, I'm gonna change the source code. I'm gonna push it to Git. I'm gonna edit, commit, push it to Git, and I'm gonna see what's happening in the system while that is happening, right? No. There you go. Okay, so the only thing I did so far is push something to Git and expect the system will do the rest. So the second rule, everything must be tracked, every action must be reproducible, and everything must be idempotent. Idempotent is very important because if you're not really operating your systems anymore, if Git is operating your system because you're not allowed to enter your systems, then everything must be idempotent, meaning that if you try to deploy the same thing twice, nothing bad happens. And what that means is that you're not allowed to write scripts anymore, like shell scripts. And PowerShell you were not supposed to write long time ago. You write some kind of declarative statements. We're going to get there soon. And if you're confused, that's because you probably did not understand yet what is your role in what you're doing. And your role is not to be a normal worker, right? You are kind of, think of yourself as aristocracy, right? Imagine that you're all kings, queens, princesses, whatever you are, right? You're not doing dirty work, right? Dirty work is done by machines, right? So if you're, for example, one of those people who goes to a web page and click, and say first test case completed, you're just a worker, right? You're not leveraging the system as you can, right? So we are all aristocracy, and aristocracy needs slavery. We need slaves. And since that is not politically correct to say anymore because humanity moved forward from there, we're going to call them agents. And our agents are, that's slavery, our agents are computers, right? They're processes, they do our bidding. We don't do things. We just command, computers do stuff for us. And for that to work, it needs to be asynchronous, right? You cannot have synchronous processes anymore because there is a very limited amount of things you can do in synchronous fashion, right? And imagine, just to demonstrate that, imagine if you would go to a restaurant and you would synchronously request something and then wait until plants grow, tomato grows, and then you wait until cows are old enough and somebody brings it from a farm, and then you go to a kitchen and you look at the cook and say, I'm going to watch you while you're preparing my meal, right? You don't do that in a restaurant. When you request a burger, you just do something else. It's a synchronous action. You say, I want a burger. You receive acknowledgement saying, yes, sir. And you continue drinking, getting drunk, or speaking with friends, or whatever you're doing while asynchronously things are happening in background. We are not monitoring things synchronously anymore. And simply because that does not scale, and that not many things can be done in parallel when things are synchronous. So the third rule is that everything needs to be asynchronous, meaning that you fire something and that you don't wait until it's happening, you just continue doing something else, right? It's very simple, very straightforward. So what that also means when we combine those things so far is that we are allowed only to push things to Git. And therefore, by the logic of things, Git is the only one allowed to propagate some information to the system, right? We use webhooks. Webhooks would notify the system saying, look at this guy. He wants this fancy stuff. Go and do it for him, right? So you have access to Git, Git has access to your system. And for all that to work, you need some kind of a butler, right? Because imagine that you are, imagine that you live in a palace. By the way, this is Buckingham Palace. I think that they have almost 200 servant rooms, a lot of people serving, and what people do there usually when it's not goes into press, that they get drunk all the time, and that they start breaking stuff, and then automatically, and they never communicate directly with servants, with people who are doing stuff for them. They have a butler who say, I need a meal, and he goes around and orders things to everybody around, right? So you have somebody who decides stuff, that's aristocracy. You have somebody in between who accepts those requests, and you have somebody at the other end, many different agents that do their bidding, right? Very often, guys over here, they don't even ask, say I'm hungry. People, somehow they know that they're hungry. And as I said before, you break stuff, and then automatically things get fixed. And those things get fixed, not because you are fixing them, not because Butler is fixing them, but because somebody is monitoring the system all the time. And whenever something goes wrong, that agent, Butler, commands and assembles the army of people to fix things, whatever that. It's not witchcraft, it's not wizardry. Simply there is a very clear order of how we do stuff. Meaning that I express my desire, I tell it to you, and you propagate that information to everybody in the system. And that everybody in the system is a lot of processes, an army of processes doing stuff for us. So, and for all that to work, now to have an army of processes, doing stuff, something, there need to be some form of serverless, right? Not everything, but many things needs to be serverless. And its reason is very simple, because if it's long-running processes, then you need to always have capacity for the biggest possible traffic amount of things happening, right? You need to have always 1,000 servers, even if actually, for example, at this very moment, you need 10. Like, for example, who is using Jenkins right here? Okay, you're not at work, as far as I see. Is your Jenkins running right now? Is it doing something? And are you paying for those resources? I mean, those of you running on-prem, you think that you're not paying it, I know, but those of you running in AWS, Azure, and stuff like that know better. So you have right now, most of you have Jenkins. Most of those Jenkinses are not doing much or anything, and you're still wasting CPU, you're still wasting memory, and you're probably complaining to your infrastructure department saying that we don't have enough capacity, right? So for that to work, for all that to work, processes need to run only when we need them and never when we don't, because otherwise it's a huge waste. So that brings us to this picture that we are commanding something to Git. Git communicates with, here it says Jenkins. Forget about Jenkins. It can be, actually, it can be Prow. For anybody knows what Prow is? No? Okay, so do you know what Kubernetes is? Okay, so Prow is CI/CD. No, it's not CI/CD. Prow is the way how many projects that you don't know of, but you should, do Git chat, meaning that Prow accepts signals from Git and propagates those signals somewhere else. And it also returns back to Git, so that when you type /meow, you get a picture of a kitten. When you say /approve in Git, you move forward and so on and so forth. So basically, Prow is a project that interacts with between Git and the rest of the system. But anyway, that's not really important. You can call it Prow, you can call it Jenkins. That changes every once in a while. What really matters is that we get pods. Since you all know Kubernetes, you know the pods. Pods are being created, pods are being destroyed. They don't run when we don't need them, right? Very simple logic. So let's take a look at, just to prove you what I have here. Now this is still running, so I need to speak. Oh no, it's finished. Can you see this? Is this big enough? You're not going to tell me? Excellent. So this is my whole CI/CD system. Now it's hard to see because it scrolls, but I dare you to find me Jenkins here. Anybody sees Jenkins? There is no Jenkins. For for quite a few different reasons. What there is are those here pods that are all completed. When I created a project, a process started, it did something with that project, it compiled it and deployed it to the staging environment, it ran some tests, it blah, 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 blah. And when this finished, the process died. Same thing for deploying to staging, same thing when I made a commit, and so on and so forth. So none of those things are running when they're not needed. They're created when needed and destroyed when not. This is serverless. Just not serverless that you might be used to, like lambdas or lambdas of the world and whatever they call it in other providers, but nevertheless still serverless. And this cluster itself is also very elastic, right? I have 3 nodes right now. If I need 10 more, there will be 10 more. If I need less, there will be less. Okay, so serverless is a must. So what else? You need to store your binaries somewhere. Now, that's the only, so binaries are not really source of truth. Source of truth is your code, configurations, and all those things that are in Git. The rest, we don't care where it is as long as it's somewhere. And binaries, for example, when you compile your application, that's a type of binary that you are supposed to throw away because it's a waste, because you're going to create a container image, and that's something you're going to keep somewhere. You're going to create Helm, which for you not familiar with it, is how we package applications in Kubernetes and so on and so forth. You're going to create a bunch of binaries. They're not source of truth. They're not in Git. They're stored somewhere else. And that somewhere else can be different types of registries, I don't know, libraries in Nexus, container image registry, Helm registry, and so on and so forth. Doesn't matter really which one it is, but that's where you're storing stuff. So just to prove to you that magic is happening, while I was speaking to you, 2 releases of my application were created, already and stored, in this case, in Chart Museum. You see, when I created a project, it did everything it needs to do, and it stored the release 0.1, and then I made a commit, if you remember, and I pushed, and that was stored as well. I'm still on the level that the only thing I did was to push something to Git. Everything else I'm doing is just showing you the result of that something, not really doing any action, because the only action I'm allowed to do is to push something to Git. Okay, excellent. So far, so good. The next thing, and this is something that for some unknown reason I have trouble convincing people, is where do we store definition of our environment? So for example, if I ask you right now, where is definition of your whole production environment, everything you run in production, many of you will probably not tell me it's in specific production repository or something like that, right? You usually have tags somewhere, you usually have some release notes somewhere else, you usually have every repository of every application has a piece of the information, but very few really have a full definition of the whole production environment or staging environment or anyone you want in Git, right? And that's where it must be, because simply we already agreed that Git is the only source of truth. So for that to work, you need to have a repository for production, a repository for staging, and whichever environment you have. I think it's silly to have more than 2 environments, but we can discuss that as well. And that needs to be stored in Git as well, or in some branches. I don't like the idea of storing environments in branches, because if you assume that master is the only one that something is done with, if you assume that you're using feature branches, then master is the only one that matters. That means that you have to have as many repositories as you have environments. So let's double check whether this was happening as well. I'm going to show you, and this is also, none of these things is prepared. You can see the timings like 10 minutes ago, right? Now, I haven't done this in advance, but you can see here that my staging environment in this case has a definition of everything running in staging, simply because when I pushed a change, that was pushed to the master. Master is running some process and then ends up being deployed directly to staging, right? We're doing continuous delivery here live. And this is the application I built. This is the release 0.2, because initially released plus 1 push, and it's already there. And now I can reproduce my staging environment just by saying deploy everything that is defined here. Okay, so what else? Everything must follow the same coding practices, which is, again, something that everybody tells me that they're doing it and they're not. Like, for example, for your environments, are you doing pull requests? Are you accepting those pull requests? Are you merging into master, right? Because that's a good practice. Are you doing those things with tests? Are you doing those things with everything you do, right? So that's a very simple rule that you cannot have different practices on a very high level. Details can be different, but on a very high level, you cannot have one part of organization doing something, the other part doing something else, and so on and so forth. Because if we all agreed that feature branches of one form or another are a way to go, right? Except SVN, it's coming. When they make a new release of SVN, they will have pull requests as well. I can tell that with full confidence because they will never make a new release of SVN. Anyway, so everything follows the same practices. And what all that means is that you cannot use Jenkins or something similar to simply deploy something somewhere, right? You cannot create your pipeline that says, do this, do that, do this, that, do that, and then deploy, right? If you follow the logic we had so far, for you to deploy something to some environment, you need to push it to that environment, and that must initiate yet another process that will do something with that environment, right? And I can show you that as well, because what was happening in the background when, while I was talking, you will see that for some reason 3, I don't understand what I did. Anyway, ignore the third one. Pull requests were made to the staging environment to change it, right? Simply because I pushed a release, I pushed something, a commit of my application to the master branch that initiated the process. And you can see it here that, for example, it changed release 001 to 002, right? I still have the same process. I still use Git for everything, and so on and so forth. So what else? All deployments must be idempotent. I mentioned that before as well. For all that to work, if your environments are going to be defined somewhere, and if all your applications for some environment are going to be defined in the same place, then when you apply the definition, you cannot just simply install stuff, right? You need to have a system that will verify, do I already run this? If I do, I'm not going to do anything. If I'm not running it, I'm going to install it. If I'm running it, but it's different, I need to apply the differences, right? So it needs to be idempotent, and every time you run something, it needs to produce the same result. And the reason for idempotency, and the reason for idempotency is easy. To explain, I already did. But the result of that idempotency is that we are using declarative syntax for almost everything today. And the reason why we are using declarative as opposed to imperative like shell scripts is because declarative allows us that, right? Declarative allows us, instead of telling machines, do this, do that, we express desires. Like, for example, I would like to have 10 servers. You go and figure out how many I have and how many should be removed or added, right? Remember about aristocracy, we are expressing our desires. This is what I would like to have. And you, everybody else, meaning processes, figure out how to converge my desire into the actual state. And that's why we like declarative syntax. It can be YAML, it can be JSON. I don't care about the exact syntax, but it's declarative, not imperative, everything we do. I mean, except writing code, of course. So let's see whether that also works. So what I'm going to do is that I'm going to clone the staging environment that I showed you before. I'm going to go inside, slight modification for the different IP, and I'm going to deploy another to deploy my whole staging environments one more time to the cluster. I'm just running Helm apply, which is again packaging mechanism for Kubernetes. Say install everything in my staging environment and let's see what happens. I'm going to get back to that because it will take 2 minutes and I'm too anxious. So the next one is, according to all those things, which I mentioned before, but I need to reiterate again, is that webhooks are the only ones allowed to enter your system. So who is having SSH access here, or knows somebody that does, right? You're scared, I know. So the point is that, assuming everything I said so far, what's the purpose of having SSH access? If the only thing you can do is push something to Git, if Git is the only source of truth and not your shenanigans when you randomly do stuff, then what are you going to do with SSH access? There is no real reason why you would have it, assuming that you accepted that Git is where you store things, and that Git is who initiates the processes to converge your desires into some actual state. So before I go there, let's see whether this is finished. No, I'm still running apply. It will take a bit more. Any questions while we're waiting for my previous command to finish? I didn't ask. You speak English? Maybe that's the problem. No? Okay, then you can watch me pace around the room in silence. Yes. Come, I cannot hear you. Or yell. Yeah, so secrets are a controversial exception. I don't think that we have a right solution for Git yet. You can encrypt them in Git. As long as your keys are somewhere, then that can work. You can put it in Vault. Now we can debate actually whether secrets are a source of truth at all, because to me, secrets are closer to data in a database. They're just state of something. Yeah, you get them from Kubernetes Secrets or from Vault or whichever solution you apply. Anyways, going back to where I was about idempotency, I just deployed completely everything from scratch, the whole environment. And no, that's the wrong command. And if you look at my staging environment here, you can see that the age of the pod is 17 minutes. No matter how many times I instructed something to converge to desired state, nothing changes because it's idempotent, and I did not change my application already for 17 minutes. It does not really matter how much I do that. And going back to the GitHooks being, webhooks being the only allowed to go to the system, you can see that when I created a project, a new project, you need to trust me, this was done half an hour ago automatically. This is the only, basically, this is the hook, this is the webhook that is the only entry to my system from, in this case, GitHub. It can be some other GitHub account. Okay, so what else? All the tools must be able to speak with each other through APIs. UIs are great if you're a manager, right? If you're not engineer, right? So if you're a manager and you're an engineer, then you can use APIs. That's okay. Anyway, engineers, we cannot automate things by clicking, right? We know that that doesn't work for many years now, right? We know that the only way to actually automate stuff, the only way to be reproducible, repeatable, and reliable is by doing the same thing over and over again. And the only way to do the same thing over and over again is by writing some code and communicating with the system through APIs or CLIs or whatever you're using, not by clicking, right? That means that actually the best installations of Jenkins I know are installations where people working in that company never see Jenkins, right? It should be completely transparent. It shouldn't have buttons like, oh, you go to Jenkins, you click this button and something happens, right? That completely breaks all the principles. And to make things more complicated, Jenkins does not really work well with APIs and CLIs and all those things. It is UI-based system. UI first, everything else second. What I'm showing you is quite the opposite. Glimpses of the commands I showed you is quite opposite. It's a system created to be API first, CLI first, and UI comes later, right? I mean, it's already there, but it's not really the major design choice. So the Jenkins that I'm operating in the cluster right now, it works completely to CLIs, API, and all those things. And then we have UI, which is mostly, I mean, everybody can use UI, but UI is mostly meant, you know, when you go higher up, show it to your CTO and say, look at the pretty colors. Almost as nice to watch as Netflix, right? And I can show you that is because, for example, if I'm going to continue with my process of from something to from nothing to everything, the only step missing for me is to promote something to production, right? And that's now going, whomever mentioned Jira before, that's where we open 57 Jira tickets and God knows what and so on and so forth. And then somebody clicks something in Jenkins and then it gets deployed to the production. And it's not recorded anywhere, maybe some tag in Git somewhere, right? So assuming that there is no strong need for UI for engineers, right? If you're not engineers, then it's okay. I can show you UI later. What I'm running here, I'm going to promote manually something to production. So I'm not doing continuous deployment. Not every commit goes to production. I'm doing continuous delivery right now, meaning that every commit is fully verified and ready for production unless it failed. So I'm going to promote my application from staging environment to production. I'm just going to say promote application called JXGo, this specific version, to the environment production, and do it in batch mode, meaning don't ask me questions. And right now, what is happening in the background, again, exactly the same principles. You might think, your first reaction might be, oh, this is deploying to production, which is absolutely not true. What this command did is that it went to the repository dedicated to production. It changed the contents of the repository, YAML file, whatever. It updated it with the release that I want to have in production. And that repository sent through a webhook, notified the system, and right now a pipeline is running in the background. It is doing whatever is needed for me to deploy to production, and after a while, it will be deployed to production. And on top of that, it is following the same principles that we are supposed to follow. It did not just directly change, where is it? It did not change directly the master. It made a pull request, executed some processes behind pull request, then it merged pull request to the master, executed some other processes, and hopefully, if I didn't mess it up so far, kubectl, Justin, JX, production, get pods. My application is about to be running. It is pulling the image. It's almost finished in production. And you can see by the age that I'm not faking it. This was done now, not prepared. This is not a video and all those things. Okay, so summary of everything, GitOps related. You can read it yourself. Git is the only source of truth. Everything must be tracked. Every action is reproducible, and everything must be idempotent. Communication must be asynchronous. Processes should never run if they're not used. We should have processes running only when they're doing something and not longer than that. Binaries are stored somewhere. Information about everything, including your releases, must be stored in repositories where they belong. You can think of it as if your staging environment is an application in itself, and your production environment is an application itself, right? And you're treating that as such. Everything follows the same coding practices you do. If you agree to do pull requests, then you might have a different process than I, right? But if, in my case, feature branch, do something, pull request, approve, accept, whatever, review, merge to master. Idempotent, Git webhooks are the only one having access to your system, and everything speaks through APIs. Or you go to hell. That's me, that's my Twitter, my blog, buy my books. That's it. No more slides. So how many of you are doing it? Okay. Any questions? Yes. No Jira. Okay. Wait. Where is UI? Have you seen UI? Sorry. To UI? See UI? To see UI? Yes. Who told you that that UI would have ability to change anything? It's to view stuff. It's to see stuff. Yes. At least the one that we have right now. So what I'm talking about, so there is no Jenkins in Jenkins X. This is a completely new code base, right? So to understand this, step number 0, before the command and number, forget everything you know about Jenkins. And then I can teach you Jenkins X. So Jenkins is dead, long live Jenkins X. That's the summary. And it just has the same name. And some level of compatibility, which is to be discussed. Yes? From where to where? Make a breaking change to schema or data? So your schema is in repository, right? Okay, and you have some kind of system that will verify what is the current version of the schema and apply all the diffs, like Flyway, right? And then that tool would, when you check out the code through your pipeline, you would run that tool, whichever it is, that would go and see what is the state of my database, 57. What is the state in my repository, 78. So those are the steps I need to do to get my new schema to be up to date. No, not coming out of the box because it's not hard. I never said it's hard. I'm just saying that there are too many databases. But it's not hard. It's very easy. You write SQL code, right? Add column if you're talking about relational, or if you're talking about some kind of free text JSON format like Elasticsearch or Mongo, then you're not writing anything, right? That depends on you. But so the tool that will apply the deltas, there are as many as you want, right? Now, whether it's hard to write SQL or not, I would say that if it's hard to write SQL, then maybe you're in a wrong business. Yeah, you just go to your pipeline and say sh my tool run X. Huh? Yeah, sh. Yeah, but I'm not running that sh. System is running sh. Of course, it's going to run a bunch of commands. A lot of things happened there. A lot of commands were executed in a background, but I did not execute them. I changed something in Git. Git notified my system, and system did the I was about to say shitload of things, but that's not politically correct. So a lot of things, right? And as long as you know the command. So I usually suggest to people, you never start with Jenkins. You end in Jenkins. So I see a lot of people, very often people start from the scratch, start writing some Jenkins pipelines, and that's wrong, right? You go to your terminal screen like this one, you figure out the command that will do something. Once you know what you're doing, or write the script, whatever, then you move it into a pipeline. That yes. And by the way, pipelines are also kind of now switched from Tekton. Tekton is one of the tools that is in Continuous Delivery Foundations, many things. But yeah, if you know the command, then it's easy. Just copy paste. Huh? UI wise, it will be a new UI, if that's the question. It will not die, it will be reborn. So we are working hard on writing completely new code and rewriting everything, right? Because every once in a while comes a time in person's life or company's life when you say, I need to rewrite stuff I did, right? And that's what's happening. There are different variations. You can run classical Jenkins here and all those things, but so far there was not a single line of Jenkins that I showed you so far. Tonio. Anybody else? Something is wrong. Okay, so the question was, if something is wrong, how would you do rollback? Now, there are two answers to that question. First of all, if you can do rollback, then, for example, in this case, it's Helm doing deployment, and there is a command Helm revert that would revert to the previous version of your application. And so you have your pipeline that does blah, 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 and then something fails after the deployment, some verification, test, whatever, and then there is a catch statement saying, okay, then roll back to what you had. Right? That's answer number one. Answer number two is that rollback is a myth, right? So let's say hypothetical situation. Everybody, there is data always. There is no system without data. Every once in a while, we change the format of that data. And what happens when you can't change the format of the data? Let's just change the schema, and the first transaction enters the system. There is no going back, right? And the third answer is that whether you roll back or roll forward depends on the duration of your life cycle. If you're deploying every day or multiple times a day, rolling forward is easy. Now, if you're talking about waiting for weeks or months, of course, there is nothing you can do except roll back, and if you're religious, pray to God, right? Those are the only two options you need to combine together. Anybody else? It's fun. Yes, Jenkins X is made to run in Kubernetes. There is nothing today beyond Kubernetes. No, really, there is nothing beyond Kubernetes. There is mainframe that will stay forever, and there is Kubernetes. Everything in between mainframe and Kubernetes is gone. Not everybody got the memo, but now you know. Now, a few years ago, we were doubting, and nobody was sure, will it be Swarm, will it be Mesos, will it be Nomad, will it be Kubernetes? It's very clear today, Kubernetes is here to stay. Every single software vendor has a vested interest in Kubernetes today. Everybody is working on next generation of their software for Kubernetes. I'm talking about software companies. And that guarantees this. Everybody whole industry has a vested interest in Kubernetes. Kubernetes is here to stay, at least for a couple of years. Now I'm gonna come back a few years from now and I will tell you it's bullshit, Kubernetes is no more, but that's how it works. Yeah, so if you want non-Kubernetes, there is still Jenkins from before. Use it. Go to Kubernetes, please. Anybody else? No, first you need to get rid of Mesos. That's a step number one, right? And please get rid of Mesos before I come again and tell you should get rid of Kubernetes. So at least try to catch up somehow. Mesos is dead. I'm sorry to say that. Probably there is Javier here from sales. He's gonna kill me for saying things I'm not supposed to, but he's dead. It's like in the same state as my grandma, right? No differences. You just change minor is build is always incremental, and then minor is you change it yourself, and my major just store it in Git. I mean, also you can employ different types of versioning. This is semantic versioning, it can be something else. Anybody else? Yes. There is no more Jenkins file. Who told you Jenkins file? I said no Jenkins. There is Jenkins X YAML.
What's the process to merge that PR to the master branch? So if something happens.
Yeah. So merge. So merge of depends whether it's application or environment, right? Which one of the two? So 3. Okay. So for let me try to find you some example. I push directly to master, which I shouldn't, just for the sake of going fast. But normally, when I create a pull request, I would. I don't see it here. Let me see if I can find one example. Let me open a bunch of them and see which one works, if any. No. Okay, doesn't matter. I'm going to explain instead of showing. I don't know where I have it. Anyways, so you make a pull request, and you would be notified about that. And then depending on your policy, something would happen or other. Like for example, a common policy would be 2 people in some list of reviewers needs to give LGTM. Looks good to me, right? So you create a pull request, you assign it to one of those people, 1 or 2 or whatever. They review, they say it's okay, and then it's merged to the master, and that initiates another process that would end up deploying it to staging on production or whatever, right? Now, in case of environments, I had 2 environments, staging and production, and I configured that staging receives updates every time I push something to the master of my application, and production is set to manual, right? But it always, so the major difference is that whether you go review a pull request and approve it yourself, or that process is done by the system. Mm-hmm. Yeah.
Where does it happen?
Right now, it's happening in a YAML file that is equivalent to Jenkins file. Yeah, it's easy. Yeah, there is. Let me show you. Oh yeah. So if you're talking about the pipeline itself, I don't have it here because let me find it in one of the branches. Maybe here. Here is Jenkins file. Now in this one. Now what I cannot show you because I don't have it available here is the new format, which is equivalent to Jenkins file. But it is basically based on Tecton, which is that somebody mentioned CD Foundation. That's one of the applications in CD Foundation, Tecton. It has a different, it's YAML. So this is not YAML. And the reason why I cannot show you is because if I show you the application that I just built, you will not see anything because it uses Go. This is defined internally. But there is a YAML file. Yeah, there will most likely never 100% sure be a tool to transform your Jenkins file to Jenkins X YAML. Yes, that will depends whom you ask. With platform specific. You compile it in a Windows container and you compile something for Linux in a Linux container. Kubernetes doesn't work with Windows. First of all, it does. And this morning I read the news that in version 1.14, it is production ready. I mean, production ready in Kubernetes is a very loose term because most of the things are not production ready for 5 years, right? That does not prevent us from using it. But now it's official, it's production ready. So yes, Windows containers work with Windows. Now we can have a longer discussion why would you use Windows, but that's a different one. ARM. I know nothing about ARM, so I cannot comment. I know that I had a couple of projects. I started myself open source, some proxy and stuff, and I know that people were compiling it in ARM, running in a cluster as a container and all those things, but I never tried it myself. But I know it works. Failed pull request. Yeah, make another commit. Yes. Yes, you can without using UI. Yeah, you can run a command. Yeah, I don't remember the exact command, but rerun or something like that. Yes, yes. Now I don't think that there should be such a command because when you have that command, then you have the option to postpone fixing the problem in the first place. You mean one of those things that happen once every 7 years? I mean, your clusters are not really losing connection. Yeah, but you can rerun it. Yes. Anybody else? What? Once, twice. Okay. No mesos. Huh? No, it's still here. You can use it. I'm not saying that you cannot, but the new format will be YAML based, completely YAML based. Beyond YAML universe. So okay. So here's the story. There is a project called Tekton. Tekton is a low-level way how to do CI/CD in Kubernetes. It's a completely independent open source project, right? And it's never meant to be used directly. It's just a building block, right? So that YAML is being translated into Tekton tasks, which is custom resource definition in Kubernetes. So it's a Kubernetes resource called Tekton tasks. And YAML is translated into that because those tasks, I can show you the task, but and if you tell me you will write it, GTL get tasks, I think. So here is the real pipeline of my of the application I run. But this is a Kubernetes resource. This is not something that you will ever write. It was just silly, right? So that YAML is translated into Tekton tasks. No, tasks or pipelines? Yeah, like a step. Like a step. So then you have the task run, but if you do control get. Yeah, I think it's like that. Yeah. So those are my pipelines. But this is very low level, right? Huh? No, there is no truth in running something. No, nothing. But no, a code for running a task, a pipeline. Definition of that code, yes. Now, if you're talking about logs, because output of this are basically equivalent of logs. Logs. How can you guarantee? You mean, how can you guarantee that transformation from YAML to tasks will always produce the same result? Yeah, because it is versioned. So everything in Kubernetes is always versioned. Now, there can be a bug that prevents it from, but that's, yes, version, you cannot do anything in Kubernetes without having using a specific version of something. So it's never latest. In Kubernetes, it's never latest. Any API invocation or resource, so it's always version. Now, if there is a bug, that's something I cannot fix right now. Later, maybe. Anybody else? So in that case, as far as I know, you can still leverage Kubernetes to do everything, but only the part of building the binary would need to be sent somewhere on a Mac somewhere, right? Because as far as I know, it cannot be done in containers. So you don't need to go for everything 100% this, right? So you still have a lot of advantages from running processes in Kubernetes, and then parts that needs to be done somewhere else. You do it somewhere else. Delegate part. And then in that case, it would be similar to that part of the pipeline would be just attaching an agent like or SSHing or whatever you're doing. Anybody else? Yes, last question. Lucky gentleman. Yes, everything. I mean, so I don't think I would not kill you if you don't do it in Git. So it's not a hard rule. Documentation, I don't mind where you put it. Now, I think it's silly not to have it in Git, right? I think it's silly not to write documentation in Markdown or something like that and put it in Git because it's simpler. But now, if you like writing in Word documents, I don't really care because the real documentation is code. That's what really, really matters. Now, if you want to put it somewhere else, be my guest. I mean, I myself, I do absolutely everything documentation. Actually, even articles and books and stuff like that, always in Markdown and Git. And then you have a process transforming it into whatever output you want. But that's not a hard rule. I don't care. Okay. Thank you very much. Have some pizzas, beer, Coke, all those things. X-Force.